My name is Hamed Ekhtiari, delighted to be here, and great speakers, Travis, Rita, and I'm going to follow the discussions in terms of how to individualize dose and target optimization with using neuroimaging for addiction neuromodulation. So I do not have any conflict of interest. Before getting started, I should thank my colleagues and collaborators at Laureate Institute for Brain Research, University of Minnesota. I already have some of those colleagues here, and many thanks to their support, and also my team members who are, Ghazal and Arash are here, so many thanks to all those people who have made those things possible to happen. So when we talk about addiction, TES, TMS trials, we are talking about kind of around 200 trials, more than 200, up to kind of end of June 2023, we have 227 trials using TES, TMS, starting from 2003, 2007, and then boom, just going up, and now we are expecting to have more and more advanced trials in the field. And what is happening here, as you can see here, if you put all of them together, there is something like an overall effect on craving and consumption. Whether we are talking about TES or we talk about TMS, and we are talking about thousands of patients, from like 3,000, 2,000 for TES. So the field is growing, but as you can see, this is the meta-analysis. So you see there is a mild to moderate effect for TMS, mild to moderate effect for TES, craving, consumption. So there is a signal there, but the challenge is when you go to the details of those studies, they are targeting multiple different areas around the brain. So it is not just about one single area. It's just that they are sometimes shooting in dark in different places in terms of what would be the right target. And when you go to details, you can see there are areas that people target more like PFC, frontopolar cortex, insula. But people are targeting different areas in the brain. And the question is, even when we go for one single area like DLPFC, people use different ways of targeting DLPFC. So they use basically a skull-based measure, something like finding M1 going 5 centimeters ahead, or using EEG coordinates, just basically anatomical targeting. So people use different ways of targeting DLPFC. But if you go to other areas in psychiatry that people use brain stimulation, you can see people go beyond these 4 measures. So they go for using metabolism like fMRI activations and talking about connections, how we can use connections. And then going beyond that, right now there is an ongoing discussion in terms of personalized targeting for neuromodulation addiction and how that could be happening. When we talk about depression, there is an ongoing discussion in terms of potentially targeting DLPFC connection to subgenual cingulate cortex, but the question is, what would be the right target for addiction? And how we might be able to find the right target. Rita was talking about some of the targets, Travis was talking about some of the targets that we have, but what would be the right target? So we are looking into the potential targets. This is a model that we are working on with Ghazal, my postdocs, over here, and trying to see what are the areas and how they could be potentially related in terms of we are tapping into the same network when we are trying to find the right target for drug addiction. And kind of giving you a little bit of evidence in terms of what are these targets, how these targets are working. And starting with something like a frontoparietal network or executive control network. We are in a neuromodulation conference. People are discussing a lot about frontoparietal synchronization using TACS, things like that. So this is the way that we target frontoparietal network. So we started with kind of putting the electrodes on F3 and F4, and then putting the parietal electrodes over P3 and P4, trying to engage frontoparietal network. But with those electrodes, then we have been kind of measuring the level of engagement of frontoparietal network. We realized that those networks, that specific network is not engaged in drug cue reactivity. We had negative connections between F3, F4, P3, P4 when we are talking about drug cue reactivity. So the connections that would be enhanced when you are exposed to drug-related cues. But there was no engagement in frontoparietal network. But we have been expecting to have an engagement in frontoparietal network because when you are seeing drug cues and you are a substance user, your executive control network would be involved trying to control your craving. So we put the modeling over the frontal areas, and we have been thinking, okay, is there any area in the parietal network that would be engaged? And we realized, yes, there is an area which is connected to frontal side, but the area is a little bit kind of the other side compared to P3, P4, and we realized that it's basically on CP5, CP6. And when we change the site of the electrodes, we realize that yes, when we change the site of the electrodes CP5, CP6, those areas are highly engaged in drug cue reactivity. So even when we talk about frontoparietal network, it's important to think about which frontoparietal network we are talking about and which one is actually involved in drug cue reactivity and how we are going to engage that specific network. Then thinking about how to optimize the dose of the stimulation, if you put the electrodes on frontoparietal F3, P3, and F4, P4, you see that, and put 2 milliamp of electricity inside, you can see that there is like a same sort of distribution of electrical current. These are each individual. This is 60 participants with methamphetamine use disorder, and there is sort of balanced distribution between both sides in terms of the amount of electricity that they receive. But when you put the electrode on CP5, or to change from P2 to CP5, you realize that the side that you have on the CP5 would receive higher level of electricity, because basically here you have less skull thickness and the electricity would go further inside. So if you want to have a balanced stimulation on both sides, you basically need to decrease the level of electrical current on the parietal side. You need to optimize. If you want to go for different sides, you need to think about how you are going to optimize the dose. So it is not about only the delivering the current, but also about what would be the level of current that would be received on that part of the brain. And this is in a group level analysis. And we put together a paper discussing about those things, but that paper is specifically available, so if you want to take a look inside. But going beyond that, now we are basically doing that, what we call concurrent TES fMRI. So we have been able to put a group of people together discussing about how to actually do electrical stimulation inside the scanner, and now we have an ongoing trial specifically on frontoparietal engagement using drug cue reactivity synchronized with electrical stimulation inside the scanner. So that is a kind of a way to engage that specific network. But going on the other sides of this stimulation, we can also think about DLPFC as just a single target for stimulation. So this is one of the first studies that we work in this area. One of the first studies in mental use disorder. 30 participants with crossover design. So we targeted right anodal and left cathodal stimulation. And we showed that we can basically decrease the level of drug craving doing F4, F3 stimulation with TDCS. But then we have been looking into the kind of the stimulation. It's quite interesting that even in the meta-analysis level, when you put all the studies, there are 24 studies with F4, F3, and 14 studies with F3, F4, and they both have significant changes in consumption and also craving. So these are probably the most frequent protocols in TDCs that people have done, and in our meta-analysis, there is a significant effect in the group level among different studies. But interestingly, when you do head modeling, you realize that you're not actually targeting DLPFC here. When you put the electrodes over F3 and F4, the highest level of electrical current is actually on the frontopolar area. So you are stimulating frontopolar area. Whether you put electricity on F3, F4, F3, or F3, F4, you are technically targeting frontopolar area. And the challenge is, this is 60 people with methamphetamine use disorder. As you can see here, people will receive different levels of electricity. So there is variation in terms of the received dose of electricity among different participants. And we showed in the preliminary study that that level of electricity and the fMRI response to electrical stimulation would be correlated in frontopolar cortex in terms of there is a sort of dose-response relationship in frontopolar cortex when you put electricity inside the brain. Interestingly, we have a nice publication from Michael Fox team recently that they showed basically one of the major nodes that would be involved in changing drug use behavior among nicotine users and alcohol users in a network would be frontopolar cortex. And you can see that these nodes are pretty overlapping. So, I mean, they show that this area would be important for changes in kind of using alcohol and nicotine in a lesion study, and this site is pretty much overlapping with the frontopolar site that we have been discussing about. And also, it might be interesting that in our fMRI drug curiosity studies, we have engagement of that frontopolar site as well. So I contacted Colin Hanlon and I asked Colin, I mean, we have methamphetamine and opioid use data. Are you interested to share your cocaine and smoking data? And she shared her data with us for alcohol and smoking. And both data sets, they also have frontopolar engagement. So it seems that it is an area that is involved also in drug cure activity. So, I mean, it seems that there is a level of converging evidence that that might be an area that is involved in craving, but also important for target engagement in neuromodulation. Also, there are pieces of evidence that the H4 coil that is being used for smoking and has FDA approval, it also engages basically frontopolar network. And also the H7 coil that they are running new studies for alcohol, and they showed some signal there, is also basically engages the frontopolar area. So it seems that there is a converging evidence on that. And also this is an area that Colin Hanlon is targeting her studies for frontopolar area. So there are pieces of evidence that this area is also be engaged on those studies and could be important in the field. So we published a paper discussing about all those levels of converging evidence of the effect of neuromodulation on areas that, and especially on frontopolar cortex, and the importance of that area potentially in the future studies. But thinking about how to target frontopolar cortex and how we can engage frontopolar cortex. There is a nice paper from Elliot Stein, Kim, and Brian Adenoff that they showed that the cortico-amygdala coupling is a marker of relapse. Okay? Interestingly, when you go inside the paper, they realize that the connection between left central-medial amygdala and VMPFC, and the area that they are talking about VMPFC, includes frontopolar cortex, which is quite interesting. That connection was a predictor of relapse. So we put an extra analysis in our database targeting frontopolar cortex and see where frontopolar cortex is engaged inside the brain. And there is one node in left central medial amygdala, same area, and also a node with negative connection in right DLPFC. So it seems that that is a network that is also engaged in drug cure activity that we have. This is the methamphetamine database that we have. So that's an interesting area. So we started from that sort of node in left central medial amygdala, the connection to the frontopolar cortex, and we tried to see if we want to do that in an individualized way in terms of finding the right target for each individual participant on the frontopolar cortex, what would be the level of variation that we will get? As you can see here, this is X, Y, Z space, and these are each, 60 different individual participants, 64, I think, from methamphetamine use disorder, and we can see that people have different maximum target for engagement with TMS. So that is a protocol that we are working on, and it might be interesting that that individualized connection would also be related to the level of craving that people would experience after scanning. So we are putting together a specific protocol optimizing location for engaging frontopolar amygdala network, and then optimizing the coil orientation, and even kind of trying to use the robotic arms to be able to optimize that, and also at the other level optimizing the dose in the individual level to be able to have the 7 level of received dose. And we put together the protocol so you can find the technical pathway and analytic pathway that you can use. Overall, we feel that, we have something like at least dual target in the field with converging evidence that we have. One on DLPFC side, the other on the frontopolar side, and with engagement of not just a converse center as striatum and amygdala. And this sort of dual model is probably something that we are going to kind of dig more into. And we also have a parietal side to that network. So that's another level in terms of our team that are trying to kind of tap into the parietal part that might be another target for engagement of executive control network. And using that in a sort of individualized way, we can basically kind of do individualization both for the frontopolar and here engaging the same network. Going beyond that, there are hopes that we can also have what we call closed loop stimulation. Recently, we have been able to do the stimulation inside the scanner to be able to record frontoparietal engagement when we are exposing people to drug-related cues, and meanwhile optimizing the frequency and the phase of the stimulation inside the scanner. If you are interested to look into the technical report, we recently put together some of the pieces of data that we are working on in a technical report that you can use. Take home notes. So there are discussions in terms of what would be the right target for addiction. And of course, there might be potentially multiple biomarker targets for addiction. There is a large inter-individual variation that we need to consider. The targets should be spatially optimized. We can optimize things in the group level. Also, we can optimize things in the individual level. And also, we need to think about dose optimization, because dose is also an important issue to be optimized. And there are an ongoing discussion in terms of, is there any chance that we can predict who is going to be responding to DLPFC stimulation and who is potentially going to be responding to frontopolar, or is there any good way of combining them together to have better outcome? And of course, there are challenges in terms of how to optimize the intervention. So last few ideas. So when you look into the trials that we have in the field of addiction neuromodulation, they are distributed around the world. So we in the US, we are contributing to 22% of the trials in the field. So there are multiple other countries who are engaged. And we realize that we need to bring everybody on the table to be able to collaborate together to increase the quality of research in the field. So we developed a network that is called International Network of TSTMS Trials for Addiction. And we are going to push that forward. We published our first consensus statement with Colin Hanlon 2019, and now we have 54 labs that are members of this network, and many colleagues like Rita, Travis, I mean, there are members of that network that we are working together. Even during the pandemic, we put together a specific guideline for using TMS-TES during the pandemic, and also we have a YouTube channel that, I mean, we put the videos on YouTube channel, lots of webinars that we had before. We had a meeting on basically Wednesday, and we recorded all the videos. We are going to put them on that YouTube channel. If you are interested, just look for INTOM Network. You can find the network, and you can just use the videos there. And the last thing is we basically develop what we call a living systematic review and analysis in the field, and basically collecting all the new trials, trying to track what is happening in the field, and having an updated idea about what is actually how the field is moving forward. And the last slide, the last consortium that we are working on. So we developed a consortium called Addiction, Craving, and Curiosity Initiative Network. We started the consensus statement published in Nature Protocols. We have recently published another paper in JAMA Psychiatry, Rita, many others. I mean, there are many people who are involved in that network. And we are collecting fMRI drug curiosity databases to be able to use them for developing biomarkers, developing targeting biomarkers, and see what will be the biomarkers that will be consistent across different databases and different settings. And now we are realizing that there are at least 200 trials, addiction randomized clinical trials, using fMRI as an outcome measure. And we are inviting them to a new consortium within Edigma Addiction, which is called FOMI, and it's about fMRI as an outcome measure. So we try to see how that could be the next level of international collaboration on developing biomarkers. And thank you very much for your attention. And I should thank my colleagues and collaborators, especially Ghazali, who's here. If you are interested to share any databases, Ghazali would be happy to give you an idea in terms of how we are basically receiving databases from different sites. RS is on the back of the room. So hopefully we'll be able to encourage a few other labs who are interested to join the network, and we are here to help. Thank you very much.